Hey Chemistry, Mrs. KJ here, going over lesson 1.17, metric system, derived units. SI derived units are used throughout chemistry. In this lesson you will learn what SI derived units are and how to solve problems using SI derived units. Derived just means that you're going to multiply or divide. In other words, you're going to do a calculation in order to get it. So you have your metric base units. They combine by multiplying or dividing to form the metric derived units, such as the units for density, force, and volume. Here's your study guide. Combinations of SI base units make SI derived units. The metric system has 7 base units. Okay, close your eyes. We'll kind of do like a pop quiz. So meter measures what? Length. Kilogram measures mass. Kelvin measures temperature. Second measures time. Mole measures amount of a substance. And the next two, it's fine if you don't know. Candela equals light intensity and ampere equals electric current. All right, close your eyes again. Let's make sure you know your abbreviations. M stands for meter. kg stands for kilogram. Capital K stands for Kelvin. S stands for second. MOL stands for mole. All right, you can open your eyes. Combinations of these units will result in SI-derived units and are used to express quantities such as volume and density. If there are any of these you didn't know, when I was going through them, make flashcards. You need to know those all year. Time is measured in seconds, a base unit of the metric system. Use meters to derive area and volume. A liter is an SI-derived unit of volume. Volume is a measurement of three-dimensional space. So in other words, length times width times height. Measurements of volume are derived using meters. Derived meaning we had to do a mathematical calculation. Start with a unit of length, such as a centimeter, which is 1/100th of a meter. Make a square with 4 centimeters at right angles to each other so that each side is 1 centimeter long. You have now derived a unit of area, 1 centimeter squared. Okay, so here's 1 centimeter, 1 by 1 by 1 by 1, or length times width, you have a centimeter squared. If you then add a height of 1 centimeter to your square base, you have created a cube. The dimensions of that cube are 1 centimeter on each side. And now you have the derived unit of volume, 1 centimeter cubed. So 1 centimeter times 1 centimeter times 1 centimeter equals 1 centimeter cubed. Because centimeter times centimeter times centimeter equals centimeter cubed. When the metric system was invented, the unit of volume was called a liter, capital L, which was derived from a cube of 1 decimeter, 10 centimeters on each side. 1 liter equals 1 decimeter cubed equals 1,000 centimeters cubed, or 10 centimeters times 10 centimeters times 10 centimeters. So again, you can have length, area, which is length times width, or volume, length times width times height. And there you can see centimeter times centimeter times centimeter equals centimeter cubed. Density and concentration are measured in SI-derived units. Density is an important physical property of substance. The kilogram was originally defined as the mass of water in a container with a volume of 1 liter. Because 1 liter was equal to 1,000 cubic centimeters, and 1 kilogram was equal to 1,000 grams, the density of water became 1 gram per cubic centimeter. Because density equals mass over volume, 1,000 grams divided by 100 cubic centimeters equals 1 gram per cubic centimeter. And there is a typo here. This should be 1,000. So 1,000 grams divided by 1,000 centimeters cubed equals 1 gram per centimeter cubed. So the units of density, which are grams per centimeter cubed, are SI-derived units. So again, because we started with the bases of grams and centimeters, and we divided them, therefore we came up with grams per centimeter cubed, and that makes it a derived unit. The concentration of a solution, such as sugar and water, is measured in grams per liter or moles per liter. Energy can be expressed in calories and joules. Many chemical reactions give off or absorb energy. So how is energy measured? One common non-SI unit of energy is a calorie. A calorie is the amount of energy it takes to raise the temperature of 1 gram of water by 1 degree Celsius. As in, yes, the calories that you eat in your food. That's the same thing. For example, 100 calories is the amount of energy required to raise the temperature of 100 grams of water by 1 degree Celsius, or of 1 gram of water by 100 degrees Celsius. The SI unit of energy is the joule, like jewelry, joule, capital J. A joule is defined as the amount of work or energy that has the units of N times N, which is Newton, meter, or kilograms times meter squared over second squared. You are probably expending 100 joules of heat energy every second that you spend reading this screen. 1 calorie equals 4.186 joules, so the conversion factor is 1 calorie is the same as, or 1 calorie per 4.186 joule. Food calories are a little bit different, okay? So don't be confused. In chemistry, a calorie is a lowercase c, okay? It's the same idea, but it's a different amount than the calories expressed on a food label. Food calories are written as capital C. 1 food calorie equals 1,000 heat calories. So it's really 1 capital C calorie equals 1,000 lowercase c calories, because the numbers would just be way too huge if we use this for food. The SI unit of energy is the joule, named after 19th century physicist James Prescott Joule. The chemistry of reactions involving heat energy and rates of reaction involve other SI-derived units. When you study the topic of thermodynamics, okay, what does thermal mean? Heat, so the dynamics of heat, you will run across derived quantities used in answering questions like these. How much heat energy is stored in a substance? This is called specific heat capacity and has the SI-derived units of joule per quantity grams times degrees Celsius. 2. How much heat is given off when a substance is burned? This is the heat of combustion and has the SI-derived unit of kilojoules per mole. How much heat energy is required to change the state of a substance? The heat of fusion is the energy required to change from solid to liquid, and heat of vaporization is the energy involved in changes from liquid to gas. The units for both are kilojoules per mole, and we're going to get to that. So don't freak out about it yet. We'll get about it. So I guess that means you can freak out about it later. Haha, but I'll help you through it. The amount of heat required to change a solid to a liquid is called the heat of fusion and is measured in kilojoules per mole. Do you see now why I'm almost harping on the fact that you need to know your units? It's because we are going to be doing so many types of story problems this year. I promise you, it will be so much easier if you know your units. Force and pressure are measured in SI-derived units. The SI unit of force is the Newton, capital N, named for Sir Isaac Newton. Newton described forces in his laws of motion. The Newton is an SI-derived unit based on SI base units of mass, distance, and time, and is equivalent to kilograms times meter per second squared. Pressure is defined as force per unit area. You know that the SI unit of force is the Newton, and an SI unit of area is a square meter, meter squared. So the SI unit of pressure is equal to newtons per meter squared, or kilograms times the quantity, meters times second squared. The SI unit of pressure is called the Pascal, abbreviated capital PA, which was named after Blaise Pascal, a 17th century scientist who studied gases. Pressure is measured in force per unit area. In the English system, use pounds per square inch when checking tire pressures. The volt is an SI-derived unit for electrical potential. Electric current flows because of the electrical potential difference between any 2 points. This potential difference is known as voltage. Voltage is measured in volts, an SI-derived unit. The volt was named after Italian physicist Alessandro Volta, who studied electricity. A volt has the units of kilograms times meter squared per the quantity amperes times second squared, and is another example of SI-derived units. A voltmeter measures the difference in electrical potential across 2 points. So if it's 3 here and -2 here, it would be measuring the difference of 5. That's a very basic explanation of voltage, but it's kind of a nice idea to know what they mean by potential difference. It's just you're taking the measurement at one point to the other point, and you're seeing how far apart it is. SI-derived units are used throughout chemistry. Metric system or SI base units are combined to make derived units. Derived units are used in many areas of chemistry and include the following: Liters, capital L, or centimeters cubed, measure volume. Grams per liter or moles per liter, measure concentration. Joules, capital J, measures energy. Joules per gram times degrees Celsius is specific heat capacity. Kilojoules per mole equals the heat involved in changes of state or phase changes. Newtons, capital N, which is the same as kilograms times meters per second squared, measures force. Pascals, PA, newtons per meter squared or kilograms divided by meters per second squared is pressure. Volt, capital V, or kilograms times meters squared divided by the quantity amperes times seconds squared is for electrical potential difference. So you have your base units, such as meters, and you combine, you multiply or divide to form metric derived units, such as density, force, and volume. Okay, you don't need to memorize all of these, especially not right now, so I'm going to go to the notes now and just really talk through what you should know from doing this lesson. So here are the notes that you need to know for this lesson. 1.17, metric system derived units. In this lesson, you will learn what derived SI units are and how to solve problems using SI derived units. I know we really didn't do any problems. We're going to hit those in the next section, 1.18, as there is not a quiz after this section. Keywords and pronunciation. SI derived unit is an SI unit that is the result of a combination of two or more SI base units, also known as a metric derived unit. So multiply or divide base units to make derived units. Example, grams per centimeters cubed equals the unit for density. And it was derived because you started out with two other units. Make sure you know the metric system's 7 base units. Okay, so make sure you know all these. Sorry about that clicking up. I'm trying a new mouse. And you do need to know these quite possibly for the quiz. So I know I said earlier that you really didn't need to know these. They might be on the 1.18 quiz. So candela, CD, is light intensity. Ampere, capital A, is electrical current. And then the derived units you should know. Liters, or centimeter cubed, is volume. Joules measures energy. Newton, capital N, is force. Also know a calorie is the amount of energy it takes to raise the temperature of 1 gram of water by 1 degree Celsius. So again, if you don't know these off the top of your head, without looking at them, you need to practice. So print these off and give them to your brother or sister and have them quiz you, or have your mom quiz you while you're drying the dishes at night. Okay? It will make you happy because you know your units. It will make her happy because you're studying and helping doing dishes. All right. Talk to you next time. Bye-bye.